we're going to dive into a really strange paradox in how we work. How the more help we add to solve a problem, the less we actually seem to get done. And this isn't about bad managers or lazy people. It's about invisible, structural forces that hijack our best intentions.
So let's pull back the curtain and see what's really going on.
We've all heard this 1,000 times, right? Many hands make light work. It's, the bedrock of teamwork. You've got a huge task? Simple. Just throw more people at it. It's just common sense.
But then you have this observation from computer scientist Fred Brooks. And what he's saying is, our default solution, adding more help, doesn't just fail to work, it actually makes things worse. And that right there, that's where our investigation begins.
So picture this. It's a scene we've all been in, or at least heard about. A project is falling behind schedule. The deadline's getting closer and the pressure is building.
So, what's the logical move? Well, the manager does the only rational thing they can think of. Bring in more people. Get some fresh hands on deck to push it over the finish line. It seems like the only responsible choice to make.
And yet, what happens next makes no sense at all. The project, now with all this new help, doesn't get faster. It actually gets slower. The deadline gets missed by an even bigger margin. So, what is going on here? The answer has nothing to do with the people. It's hidden in the structure of the system itself.
Yeah, this is what we're calling the paradox of help. The very thing you do to fix a problem ends up making it worse. And to really get why this happens, we need to picture what the work actually looks like.
Let's imagine the project's output, like water flowing through a single, simple pipe. With one person or a really tight-knit team, the flow is clean, it's direct, there's a clear input, a clear output. The system is about as efficient as it can be.
Okay, but what happens when we try to get more water through the system by adding another source? This is where you start to see the hidden cost of adding more connections.
So we add another pipe, right? Another person, another team. Logically, this should double our output, but it just doesn't, because those two pipes aren't separate.
To get their work to flow together, you need something new. You need a junction, a point where everything coordinates. And here's the key. That junction, it isn't productive work. It's something extra that's only there because we added more help.
Okay, let's see how this starts to scale up. 2 people, 1 connection between them. Easy enough to manage.
But add just one more person, and now you have 3. The number of connections doesn't just go up by 1, it triples. Suddenly, everybody has to coordinate with everybody else.
And this pattern just picks up speed. By the time you get to 5 people, you're not juggling 5 lines of communication, you're juggling 10. It's not growing in a straight line. There's this invisible complexity just exploding underneath the surface.
Okay, let's take it even further. 10 members. Now you're dealing with 45 connections. 45 different channels where people need to talk, integrate their work, get aligned. And that is a massive, hidden burden on the whole system.
This burden, it's like an invisible tax. It's a cost you can't see on a spreadsheet, but it's bleeding the one thing you can't get more of: productive time.
And here's the name for it: the coordination tax. The idea is that every single person you add has to pay it. It's all the time you spend in meetings, writing emails, sorting out disagreements. The stuff you have to do just to keep everyone on the same page, but isn't actually the work itself.
So if we go back to our pipe analogy, that simple little junction we added, well, now it's a huge tangled junction box. And instead of making things faster, it's become the main bottleneck, the very thing slowing everything down.
And at this point, the system is sliding into something really hard to get out of. It's walking right into the coordination trap.
So you might be thinking, why not just, remove some people, simplify it? Well, because it's too late. The work itself has changed. Everything's been broken down into these tiny pieces, spread across the whole team. All those pieces now depend on each other. If you pull one person out now, the whole thing could just fall apart.
And this really gets to the heart of it. On one hand, you have this totally rational action, let's add an expert. But on the other, you have the system's consequence. You just added a whole bunch of new communication lines that all need to be managed.
There's actually a name for this phenomenon. It's called combinatorial explosion. It's this mathematical principle that says when you add a few things to a system, the number of potential connections between them just explodes. The complexity grows way, way faster than the team does. And this isn't anyone's fault. It's just math. It's a property of the network you built. So, back to our pipes.
The system has now reached its final form. This whole tangled mess of pipes and junctions, it's permanent now. Yeah, it's clogged, it's inefficient, but it's also stable. It would actually cost more to try and rip it all out than to just keep it running. The system is locked in.
So what really happened here? I mean, from the outside, this looks like a total failure. But if we try to see it from the system's own point of view, a different story emerges.
The system didn't fail, it just gave up on its original goal.
Instead, it adapted. It reconfigured itself to deal with all this new complexity.
So its new purpose, its real purpose, isn't to get the project done anymore. Its new goal is just to manage itself, to manage that massive web of connections it created. The system's job is now to keep the system going.
And the actual work, the whole reason the project started, that's become secondary. The main job now is just coordination.
And this isn't chaos. It's not a breakdown. It's a new logic, a new, stable order. The system isn't failing at all. It's actually succeeding perfectly at its new goal, which is just to coordinate. And that leaves you with a pretty unsettling question, doesn't it? How many of the systems we depend on every day aren't really doing what we think they're doing? How many of them have quietly given up their original purpose and are now just busy managing themselves?